Astronomers have long been intrigued by the possibility of a hidden planet in our solar system, often referred to as Planet 9. This hypothetical planet, lurking far beyond Neptune, is believed to be possibly 5 times larger than Earth. For years, the idea of such a distant, massive object has captivated scientists, fueled by the strange behavior of distant icy bodies in the Kuiper Belt, which could be under the influence of something massive. Now, new evidence has emerged that adds weight to the theory of Planet 9's existence, offering potential explanations for these peculiarities and prompting renewed excitement within the scientific community. But what exactly makes Planet 9 so special? Why does it matter? And what have scientists uncovered about it? Let's dive into the latest discoveries, the science behind Planet 9, and explore how this enigmatic object could transform our understanding of the solar system. The story of Planet 9 begins with the unusual behavior of trans-Neptunian objects, TNOs, icy bodies that inhabit the distant regions of our solar system, far beyond Neptune. These objects, which are often members of the Kuiper Belt, have exhibited bizarre orbital patterns that have baffled astronomers for decades. Many of these TNOs follow elongated orbits that bring them exceptionally close to Neptune, before sending them back into the farthest reaches of the solar system. Even more intriguingly, their orbits are tilted at steep angles relative to the plane of the solar system, making them true outliers in our cosmic neighborhood. This peculiar clustering of orbits raised a tantalizing question. What could be causing these objects to behave so strangely? It didn't take long for astronomers to suspect that a hidden massive object, perhaps a planet, was exerting its gravitational influence on these TNOs, guiding their movements and shaping their orbits. This hypothetical planet became known as Planet 9. In 2016, Caltech astronomers Konstantin Batygin and Michael Brown published a paper that provided the first compelling evidence for Planet 9's existence. They observed that several TNOs shared similar orbital characteristics, such as the alignment of their perihelia, the points in their orbits closest to the Sun, and their aphelia, the points farthest from the Sun. This clustering couldn't be easily explained by the known gravitational forces in the solar system, such as the pull from Neptune or the distant influence of the Milky Way's galactic tide. The evidence suggested that something massive, something unseen, was pulling these objects into their unusual orbits. The only plausible explanation, according to Batygin and Brown, was the presence of a large planet, Planet 9, whose gravity was responsible for these peculiarities. To further investigate the possibility of Planet 9, scientists turned to simulations. These simulations are like massive cosmic puzzles, where each piece represents an icy object in the solar system with its own unique orbits. The challenge for researchers was to compare 2 scenarios, one where Planet 9 exists and one where it does not. In the first set of simulations, scientists modeled a solar system without Planet 9, relying solely on the gravitational influence of the galactic tide, the collective pull from stars and other mass in the Milky Way, acting on the TNOs. The results were clear. Under these conditions, the TNOs couldn't be pushed into the elongated, tilted orbits observed today. The galactic tide alone was simply too weak to explain the orbits. Next, the researchers added Planet 9 to the model. This hypothetical planet, with a mass about 5 times that of Earth, was placed in the distant reaches of the solar system. As the simulations ran, something remarkable happened. The simulated orbits of the TNOs began to match the real-life orbits almost perfectly. The addition of Planet 9's gravitational influence accounted for the strange clustering of orbits, providing the strongest statistical evidence yet that this elusive planet is out there, hiding in the depths of space. These simulations didn't just strengthen the case for Planet 9, they also helped to rule out alternative explanations. For instance, one theory suggested that these TNOs could have been influenced by a past encounter with another star, but the data didn't support this idea. Similarly, the possibility of a small black hole exerting a gravitational pull on these objects seemed less likely given the strength of the Planet 9 model. By systematically comparing different scenarios, the researchers concluded that Planet 9 remains the most plausible explanation for the TNO's odd behavior. This groundbreaking research suggests that we still have much to learn about our cosmic neighborhood. If Planet 9 is real, it would be the first major planet discovered in our solar system since Neptune in 1846. The discovery of such a planet would not only reshape our understanding of the solar system, but also raise new questions about the formation and evolution of planetary systems as a whole. For instance, if Planet 9 does exist, how did it end up in such a distant orbit? Was it captured from another star system, or did it form in place and has only now been discovered? While the recent evidence for Planet 9 is compelling, the idea of a hidden planet has its roots in earlier astronomical puzzles. Long before Battigan and Brown's work, astronomers had noticed oddities in the orbits of distant objects like Sedna, a dwarf planet with an unusually elongated orbit that couldn't be explained by the known planets. Sedna's orbit, like those of the TNOs observed by Battigan and Brown, hinted at the gravitational influence of a massive object far beyond Neptune, perhaps an early clue to the existence of Planet 9. Interestingly, the idea of a hidden planet isn't unique to our solar system. Astronomers studying other star systems have discovered exoplanets that influence their surroundings in similar ways. For example, some exoplanets have been detected because their gravity tugs on nearby objects or distorts the light from their parent stars. These so-called perturber planets share similarities with the proposed Planet 9, providing a fascinating parallel between our solar system and distant worlds. The existence of such a planet could also have implications for our understanding of habitability in the universe. Even if Planet 9 itself isn't suitable for life, studying its characteristics could help scientists better understand the kinds of environments where life might thrive or struggle to survive. For instance, if Planet 9 has moons or other bodies orbiting it, these could potentially harbor subsurface oceans or other conditions conducive to life. Understanding Planet 9's place in the solar system could thus provide valuable insights into the broader search for habitable worlds beyond Earth. The search for Planet 9 is far from over. While the evidence so far is strong, no one has yet directly observed this elusive planet. This is largely due to the vast distances involved. Planet 9 is thought to be located hundreds of times farther from the Sun than Earth, making it incredibly faint and difficult to spot even with powerful telescopes. However, astronomers are hopeful that new technology will soon provide the breakthrough they need. The Vera Rubin Observatory, currently under construction in Chile, is set to begin operations in the near future. This state-of-the-art facility is designed to survey the entire sky with unprecedented depth and precision, making it an ideal tool for spotting distant, faint objects like Planet 9. When the observatory comes online, it could finally provide the direct evidence needed to confirm Planet 9's existence. In addition to the Vera Rubin Observatory, other telescopes around the world are also being employed in the search. Astronomers are using a variety of techniques to try and detect the planet, from analyzing the orbits of other distant objects for signs of gravitational influence to conducting deep sky surveys in the regions where Planet 9 is most likely to be found. The hunt is on, and with each passing year, the chances of finally spotting this mysterious world grow. The discovery of Planet 9 would be a monumental achievement in the field of astronomy, comparable to the discovery of Uranus and Neptune centuries ago. It would provide the first clear evidence that our solar system is still full of surprises, with major objects yet to be discovered. But beyond the thrill of discovery, Planet 9 could also offer critical insights into the processes that govern the formation and evolution of planetary systems. Understanding Planet 9 could help scientists refine their models of how planets form and migrate within solar systems. For example, if Planet 9 was indeed captured from another star system, it would provide a rare opportunity to study a planet that didn't form alongside the rest of the solar system, offering clues about the dynamics of star clusters and the interactions between stars and their planets. Furthermore, the study of Planet 9 could shed light on the distribution of mass in the outer solar system, helping to explain why some regions are populated with numerous small objects, while others are relatively empty. This, in turn, could inform our understanding of how material in the early solar system coalesced into planets, moons, and other bodies. Finally, Planet 9's discovery would have profound implications for the search for life beyond Earth. By studying this distant world and its potential satellites, scientists could gain new insights into the conditions that might support life in the outer regions of solar systems. Even if Planet 9 itself is unlikely to host life, its presence could suggest that other similar planets in different star systems might harbor environments conducive to life. The search for Planet 9 is one of the most exciting quests in modern astronomy, with new evidence suggesting that this elusive planet could be lurking in the outer reaches of our solar system. The scientific community is abuzz with the possibility of a major discovery. Whether Planet 9 is ultimately found or not, the hunt for this mysterious world is pushing the boundaries of our knowledge and deepening our understanding of the cosmos. As new telescopes come online and more data is collected, we may soon have definitive answers about Planet 9's existence. Until then, the search continues, and with it, the promise of new discoveries that could forever change our view of the solar system and our place within it. Make sure you like and subscribe for more news about the cosmos.